Today we will be discussing how cloaking devices work. Even though cloaking devices are largely theoretical and can be seen in works of fiction such as Harry Potter and his invisibility cloak, they are quickly becoming things of reality and have proved to have many industrial uses. To understand how they work, first we have to understand how the human eye perceives light. Light waves of varying frequencies initially hit an object. Some light waves will be absorbed, while others are reflected back. The reflected frequency will dictate the color that our eye sees and will enable it to see the object. But what if no light was reflected back? Scientists have long theorized that objects could be rendered invisible by disrupting the way light interacts with them. If we could prevent any light from reflecting back, it would be as if the object no longer exists. Black holes work in a similar fashion. Since black holes absorb 100% of the light going into them, they are basically invisible and incredibly hard to detect. But cloaking devices take a different approach. Instead of going through an object, the light waves will be deflected around it. In order to achieve that effect, scientists will have to employ the use of metamaterials. Metamaterials are artificially engineered to produce properties that don't occur naturally. Light is a type of electromagnetic radiation which is made up of both electric and magnetic fields that are perpendicular to each other. Most natural metals can affect the electrical component, but metamaterials can affect both components. They can be manipulated to make the light bend around the object instead of going through on its natural path. The key to creating a successful cloaking device is taking advantage of the concept of the refractive index, or index of refraction. The index of refraction is a determinant of how much light will bend away from the normal when it passes through a material. When the index of refraction is greater than 1, it causes the light ray to bend inwards. Here are the refractive indices for some common materials. Air, 1.002, ice 1.31, water 1.33, and glass 1.52. Metamaterials are used to make objects with refractive indices between 0 and 1. This will result in the light ray bending away from the object and reforming on the other side. Scientists have started to develop these cloaking devices on a small scale. A research team at Duke University, led by Dr. David R. Smith, has created a simplified version of a cloaking device. Using metamaterials, the device was able to mask the object from only one type of electromagnetic radiation, microwaves. Even though this particular device only worked for one type of wave, it shows the possibility of hiding an object from the whole spectrum and masking the object entirely. The device was made up of concentric circles, with a cylinder made of metamaterials placed in the center. The object would then be placed inside the cylinder. When the Duke research team aimed a ray of microwave light at the cloaking device, the ray split, flowed around the device, and rejoined on the other side. The contraption utilized various refractive indices. The outermost concentric circle had an index of refraction of 1, and the indices gradually decreased as it went inwards. The cylinder in the middle had a refractive index of 0. This results in the microwave light subtly bending around the device. This type of technology has many practical applications, such as for military purposes. These could include cloaking military vehicles or making sure that their planes cannot be detected by radar. They can also be used for architecture or for improving the range of wireless devices. With this type of technology, the signals can just bend around obstructing objects. As our grasp on technology increases, hopefully cloaking devices will be able to be used on a wider scale for more practical applications. Thank you for watching.